Alright, this is a re-recording of part 2 because the video crashed here. So just a quick tour of where we're at already. So chapter 6, 6.1. So chapter 6 is all about equations. So think algebra, but with trig functions inside it here. So just a quick reminder, section 6.1 is about trigonometric equations. These are the basic ones that we're going to cover. These are basic equations, and it's going to involve simple things. There's your simple one. It's going to involve factoring. How do we use factoring in order to solve equations here? Then eventually a quadratic formula. That we're going to do it. And then how about things with horizontal translations? So these are considered sort of the basic trigonometric equations right here. So just a quick reminder from algebra here. The addition property equation of equality says if you have two things that are exactly the same, you can add a third element. As long as that same element is the same to both sides, you can still keep your equal sign. Same thing here. Multiplication property of equality says if two things are equal to each other, you can multiply by a third item both sides. As long as it's the same, you can still keep your equal sign. So basic algebra equation, you should be able to know this here, and again you should have just a quick review of what you've learned already here. You can move things to both sides, the addition property of equality. You can divide things or multiply things to both sides. That is called the multiplication property of equality. And then whenever you see fractions, you do want to reduce them further down. So voila, you get yourself an answer, -2/3. Again, not enough time for you to write all this down because that was part of the first video that we did for part 1. Alright, this one is going to involve factoring, so you should be able to factor this down. So two numbers multiply to -4, add to -2, that's going to be a -4 and a +2. Notice from algebra, we factor it down first into something called linear forms, and then we break it off into two pieces now. So either x minus 4 equals 0 or x plus 2 equals 0, and then solve each of those individually. So we're going to be doing that today with trig functions here. So that one, subtract 2 from both sides, gets you x equals -2. Alright, so the two answers are 4 and -2. That's what we want to keep. So this is the whole concept of factoring. Factoring method in order to solve equations from algebra. Then we have the quadratic formula. So if you can't factor something and you're just sort of stuck factoring, you can start the quadratic formula. It is x is equal to -b plus or minus the square root of b squared minus 4ac all over 2 times a. Okay, write that down if you need to. Go ahead, do it now. Write it down so that you have it on your notes. So in case we use it today, voila, use it today, you will have it here. So in this case, I don't want to factor because it looks a little more complicated. I'm going to pick out my a, my b, my c, and then at that point we're going to plug them in. So -b plus or minus the square root of b squared, which is 4, minus 4 times a times c, all over 2 times a. And I'm going to do a little bit of work right inside here. The other stuff there, that's from the other time that we did it. So -1 times 2 is -2. -2 times -4 is a +8. And 8 plus 4 is 12. 2 times 2 on the bottom is 4. Alright, when you break these numbers down, this is where the little graphic is right here. You take the 12, break it down into its multiplication tables, but really you're looking for perfect squares. So you're thinking to yourself, does 4 multiply? Does 4 multiply to 12? Does 6 multiply? Does 9 multiply to 12? Does 16 multiply to 12? Any one of those perfect squares? Yes, 4. 4 times 3, and 4 is a perfect square of 2's. So when it goes out, it's going to come out as 2√3. So that perfect square of 2's, that's what gets you that number there. Alright, what's the other thing that happens is, for these ones, particularly from algebra, hopefully you'll learn this one, is that we want to be able to reduce, and we can, from algebra, we can reduce these three numbers all at once. So what's a number that goes into 2, 2, and 4? And it's 2. So we're going to reduce each of these guys down by 2, and by 2 makes another 2, and voila, Okay, this is part 1 of the previous lecture, just doing a quick little review. So notice also there are two different answers here, right? One's a plus answer, one's a minus square root answer. So there's two answers there. Okay, I think we're almost ready. Don't forget, kind of just a quick reminder of all your trigonometric identities. Maybe even have your book cover in front of you so you have it, especially the unit circle. You probably need that. All right, these are the stuff you covered last time. So there's your degree solutions from last time. You keep on going. Hopefully you kind of reminded of that, and then we're going to go on to the new stuff here. So last time we were able to 1 through 17 every other odd. So now we're going to go on and we're going to finish up 6.1 today. So number 10, here it is. Let's go for it. We're going to answer this, and I guess a question in class was, when do you know it's degree answers that you should give, or when do you know you have radian answers you should give? And it is all about that little piece right there. And also it tells you, hey, give me all the radian solutions. So it tells you eventually you want to get yourself radian answers. Okay, so we learned last time also that it's easier to look at the unit circle first and do the B part first, and then do the A part and do all the answers. So we'll do that as well today. Let's go for it here. So looking at this, we're going to either factor or quadratic formula. So in this case, notice I see, oh, it keeps on jumping for me. Notice that I see cosine in both of these terms. Just like as if you saw something like this. Let's say you saw x minus 4. Let's say x squared minus 4x. Let's say you saw something like that. That allows us to factor out an x because x is in both terms. So same thing that happens here. We are going to factor out cosine x. We're going to factor out and leave whatever's remaining over here. So I take out cosine x, that means 1 is left, minus sign comes down, that's a 2, and that only gives me sine x only. Alright, so with this, we got two things that are multiplying each other, so let me do this here. I'm going to set cosine x equals 0, or 1 minus 2 sine x equals 0. And let's solve each of those here. So in this case, what we're thinking about is we're thinking, when does cosine give me 0? So cosine gives me 0 at pi over 2 and 3 pi over 2. There's your two little spots that it does that. So let's go down, put a b down here. So I got pi over 2, 3 pi over 2. Okay, let's come over here now. Let's going to subtract 1 from both sides. Divide through by negative 2. And we get ourselves sine of x is equal to 1/2. So now we're looking at our chart, and this is where you want to use your unit circle chart. Unit circle chart here, and you're looking for, when does sine give you a positive 1/2? I think it gives it to you at, again, this is going to be pi over 6, is that right? And then also at 5 pi over 6. There's your two radian measurements to give you that. That's going to be a positive 1/2 for the y value. So you're looking for something that looks like this, where you have a positive 1/2 in the y value column or coordinate. I'm good. There it is. So 5 pi over 6. Doesn't really matter what order you write them in, but you're good there. Okay, now the toughie. A little bit more toughie. So A is find all the radian solutions. So find all the radian solutions forever. And so if you notice for the cosine is a kind of funny one, this answer here, because notice they're exactly a half a rotation away from each other, right? Half a rotation, half a rotation. So in this case, you can combine both of these answers into one all-round answer. You're going to say this. You're going to say pi over 2. It only happens if you have half rotations. Instead of saying plus 2 pi k, what we're going to do is we're just going to say plus pi k. So we're going to only go half a rotation, and that takes care of these half rotations forever. Then let's go down to this one. This one you can't do because they're not half a rotation away. If it was over here, then yes, you would have done it. So in this case, you have to do it individually here. So this is pi over 6 plus 2 pi k. That takes care of this one. And 5 pi over 6 plus 2 pi k, where k is an integer. Alright, so there it is. We combined the stuff we got for cosine into a half rotation, but each of these needed a full rotation to go. So there's your full rotation to get to each one, which means it just cycles, right? So it means if you had, let me change color here, which means if you were here, you do one rotation, that's 2 pi, then do another 2 pi, you still wind up with the same coordinate along the unit circle. Alright, this one, let's go with it here. So, solve for all degree solutions. Now we're looking for degrees. Use a calculator around to the nearest tenth of a degree. So you could try to factor, and as you try to factor this from algebra, you can't. It's almost like factoring this, like here, 2x squared plus 2x minus 1. You can try this, and in fact, if you really want to try this at home. See if you can factor down into this little piece right here, and the answer is going to be you can't. So we're going to have to use quadratic formula. So x is equal to, there's my a value. In fact, we should say this. We should say cosine. We should say cosine theta is equal to, that's a, that is b, that is c, and hopefully you wrote down the quadratic formula from a few slides ago. It's going to be negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And that a changed into a 2. Alright, simplifying a bit further. Negative 1 times 2 is negative 2. That's going to be 8. 4 plus 8 is 12. Hey, I've seen this before, I think. And perfect square, or square root of 12 is 4 times 3, so that's 2 root 3 over 4. And then remember what we said over here, we can divide each of these by 2. So divide this by 2, divide that by 2, divide that by 2, gives us an answer of negative 1 plus or minus the square root of 3 all over 2. So remember, there's two answers here, right? So we're looking for this one. We're looking for, when does cosine theta give me a ratio of negative 1 plus root 3 over 2? Or when does cosine theta give me a ratio of negative 1 minus root 3 over 2? And so this you have to do on your calculator. You're going to plug it in this way. You're going to say cosine inverse of negative 1 plus root 3 over 2, and then just make sure it's positive, because what we really want is we want the reference angle. We want to know what's happening in quadrant 1, and then we go from there. So punch this into your calculator. Negative 1 plus root 3 over 2, and then take this cosine inverse of it, and we get ourselves 68.5, I believe. Okay, and this is cosine being positive, right? Because that number is positive right here. So now the question is this: when is cosine also, again, along the unit circle, the same? So if we kind of build this little out here, notice that if we go straight down, that is going to be 68.5, and that will be 68.5. But then the question becomes what's this angle measurement here for quadrant 4? So we're going to have to do a little bit of work. In quadrant 4, it's 360 minus 68.5. Got to do a little bit of work. So how about 5? How about 9? How about 10? So boom, boom. 1. That's 2. That's 9. 1. So 291 degrees. Okay, I think we got our B value here. B value is, got one answer at 68.5 degrees. Got another answer at 291.5 degrees. Okay. The A part. Alright, remember, so we're going to take this one and we're just going to wrap it around forever and ever and ever right here. And then we're going to take the other one. So the A part is going to be 68.5 degrees plus 360K. Those are all the rotations forever. 291.5 degrees plus 360 degrees K. And again, where K is an integer. Alright, hopefully that makes sense. This is with quadratic formula. 2 more problems, but they involve now horizontal translations. Let's do one that's a degree one, then it's a radian measurement here. So how do you do stuff where you have not just an angle, it's not sine of A, it's sine of A plus 50. Or it could be subtraction of something like that. So what we do here is we think to ourselves, that's what I'm solving for, but I'm looking for this on my unit circle. When is sine going to give me root 3 over 2? And it gives me that at 60 degrees, because you're looking for this guy. And it's also going to give me one over here. So what's this over here? So reference angle of 60 would give me, 120. Okay. So you got to hold each of those. Oh, let me put my degree marker for 50. So there's 2 different answers. A plus 50 degrees equals 60 degrees. That's what happened. Or A plus 50 degrees is equal to 120 degrees. Cool. And solve each of these. Alright, solved one. Solving the other. And we get A is equal to 70 here. Okay, so find all the degrees. So here it is. We're going to do the same thing here. So all the degrees, we're going to say A equals 10 degrees plus 360 degrees K. 70 degrees plus 360 degrees K, where K is an integer. Alright, hopefully that was useful to you there. And one last one. Find all the radian solutions here. Very similar setup. Look at number 11 to do number 12. So we're going to set this up as A minus pi over 9 is equal to sine inverse of a negative 1/2. So you're looking for, when does sine give you a negative 1/2 on the unit circle? Alright, I think I see it as 2. No, hold on. It can't be 210. You can't say 210 because we're in radian measurement here. So is it 7 pi over 6? And the other side over here is going to be 11 pi over 6. Perfect. Okay. So A minus pi over 9 is equal to 7 pi over 6. or a is equal to, a equals pi over 9 is equal to 11 pi over 6. So let's work to make that happen here. So all we got to do is really just add pi over 9 to both sides, but fraction needs common denominators. So we're going to have to, common denominator of 9 and 6. 9 and 6 has to be 18. 18 would do it. So multiplying by 2 to make that happen, therefore multiplying 2 here with 2 pi. Multiplying by 3 here, 3 times 20 is 21 pi. And I get an answer of a is equal to 23 pi over 8. This one is adding pi over 9, common denominator 18 again. So 9 multiplied by 2 to make that happen, so 2 pi, still same there. This will be multiplying by 3 to make that happen, and 3 times 11 is 33 pi. Adding them up gets me 35 pi over 8. Voila, so final answer off to the side if need be here, 23 pi over 8, comma 35 pi over 8 is my final answer. Alright, hopefully that was useful for you guys as you study the second part of 6.1.